This is Unit 2, Video 6. In this video, we'll actually do some example problems of how to write compounds. So the first example problem we'll consider is writing an ionic compound from magnesium and chlorine, made of magnesium and chlorine. The first thing you have to do is you have to find the charges of these two elements on the periodic table. What you'll realize is that magnesium, which sits right here, and the periodic table, actually a little higher up, sits right here. Magnesium has a +2 charge. That's because it has 12 electrons and wants to be like the element neon, which has 10 electrons. So we realize magnesium will have a +2 charge. That's the first thing to realize. The second thing to realize is chlorine, which is down here, in group 17, wants to gain an electron to become like the element argon. So chlorine will actually have a -1 charge. So chlorine will have -1 because group 17 is -1. So here's what we have. We have a +2 against a -1. Now the rule with naming ionic compounds is you have to match the charges up, meaning your ionic compound must be neutral. So go ahead and write these out. When we form the compound is going to be formed from magnesium and chlorine. Now we have to ask ourselves how many magnesium and how many chlorines do we add together so their charges match up. And this means we have to add one more chlorine. This gives us total a -2 charge, which now matches the +2 charge. And our formula becomes MgCl2, and that's our answer. Notice the 2 just means we have 2 chlorines to balance out each magnesium. There is an invisible 1 that we write down here, but we don't have to put that in because everyone knows it's 1 magnesium. Hopefully that makes sense. Let's try another example. Write the ionic compound formed between aluminum and oxygen. Again, you'll have to consult the periodic table, and you'll see that oxygen has a -2 charge, aluminum will have a +3 charge. Once you figure that out, we'll have to do the same thing. Let's ask ourselves how many aluminums and how many oxygens must combine together to form a neutral compound. Now, if you try to put together just one more oxygen, that gives us a -4 on the oxygen side and a +3 on the aluminum side. Well, what if we add one more aluminum? That gives us a +6 now on the aluminum side, and then we'll just add one more oxygen to make it a -6. Notice at this point, our charges have matched up. I have -6 and I have +6, which means I have determined the ratio of the compound. So I'll put down here aluminum needs 2, oxygen needs 3. The formula then is Al2O3. Notice again, these are called subscripts. These subscripts, which we've seen before, simply tell us how many of each atom is needed to form a neutral compound. This must be neutral. All compounds must be neutral, and that's the idea. Alright, how about example problem 3, which now contains a polyatomic ion. This is nitrate, the polyatomic ion nitrate. Now if you remember Nick the camel, Nick contained 3 consonants and 1 vowel, which means we have a -1 charge. So nitrate looks like this. Barium from the periodic table has a +2 charge. So because it's in group 2, barium has a +2 charge. And now we ask a similar question. How many nitrates do we need to balance out each barium? And since nitrate is a -1, we actually need 2 nitrates, like so. So we need a barium and 2 nitrates. So we get barium and then nitrate. Since we need 2 of them, we'll put a 2 down here. Now, this looks like we have 32 oxygens in this compound, which is quite a bit of oxygens. So to fix this, you actually have to say that we have 2 nitrates, not 2 oxygens. So we'll actually put a parentheses around this. This is important. Polyatomic ions will use parentheses. Use parentheses for polyatomic ions, for polyatomic ions. And actually you only need to use them when you have more than one of them. If you were to put together, for example, sulfate is SO4 with a 2- charge. If you were to put this with barium, what you would see is that barium, having a +2 charge, matches the sulfate directly. So in this case you would not need parentheses, since you'll need just 1 sulfate for 1 barium. So you only need them if there are more than 1. Alright, go ahead and try these on your own. Pause the video and try these 3 on your own. And then we're going to go on and do the opposite. We're going to undo this. Here it says indicate the charge on each ion in these compounds. Now the first compound shows chromium teamed up with chlorine. And if you take a look at chromium, chromium comes from the D block. Now in the D block we have more than one type of ion possible. So what we have to do is find out what this chromium is. Now we're going to do it from the chlorine. And since we have 3 chlorines here, I can say, alright, I've got 3 chlorines that are balancing out 1 chromium. Now chlorine does not come from the D block, and I know that chlorine coming from the P block has a -1 charge because it is in group 17. And so what I'll do in this case is I'll put a -1 on every single one of these chlorines, which tells me in total I have a -3 charge. Now the -3 charge total is balanced out by just 1 chromium, which means chromium must be a +3 charge. And that's how we get the charge. So the answer in this case would be +3 on the chromium and then -1 on the chlorine. That's what, so essentially I'm undoing the compound formula. Let's do the same thing with the second compound. This is copper and this is sulfate. Now you may notice sulfate as a polyatomic ion. Sulfate comes from supper, when Nick the camel ate some clam supper, and supper had 4 consonants and 2 vowels, so it's a -2 charge. Now, balancing the sulfate, I have 2 coppers. So here I have 2 coppers balancing the sulfate. And again, because copper comes from the D block, I don't automatically know the charge, and that's why I have to use sulfate, the charge of which is -2, to determine copper. In this case, the question is, what must each copper charge be? What must each of these be so that together they make and balance the -2? Well, each must be a +1. If each is a +1, then together you get that +2, which balances out the -2. So in this case, copper has a +1 charge. You can go ahead and write the 1 with the plus if you want. And sulfate has a -2 charge, since it's a polyatomic ion. So this is essentially undoing what we've done previously. Again, if you use this, you should be able to form the same compound as you began with. Okay? Now we're going to name these. The naming rules are as follows. The S and P block cations, there is no change in the naming. So if you have technically a metal, like a potassium, you simply say potassium. No change. It's really easy. If it comes from the D block, for the D block cations, which means metals, you do the same thing, except you indicate the charge using a Roman numeral. This is important because D block cations have more than one variety. That's why we have to indicate the charge. Remember, there are 2 types of iron, so you have to tell what type of iron you're dealing with. In this case, you say iron, and then 3, Roman numeral 3, in parentheses. So that's for the first part of the ionic compound. The second part, the anion, the second part, you simply change the ending to "ide." So here we have chlorine becomes chloride. So you don't say sodium chlorine, you say sodium chloride. And that is the rule, or these are the rules. So let's try some example problems. So in this case, we have BAS. Now, Ba is barium from the S block. S is sulfur from the P block. So remember, the first element does not change. That one is easier. We simply name it barium. The second one changes to ide. So sulfur becomes sulfide. And that's it. Simple as that. The next one, MgF2, is simply magnesium. The first element does not change. And then F is fluorine, so fluorine changes to fluoride. Notice the ide at the end, fluoride. Now you'll notice that there are 2 fluorines here, but there's only 1 sulfur here, but in both cases we just said ide. This is because the 2 is there to balance the magnesium. We know magnesium has a +2 charge, so you would need 2 fluorines. In the case of barium having a +2 charge, is balanced by the sulfur with a -2 charge. That should be -2. So we don't need the 2 there. Okay. The next 2 actually come from the D block. So both copper and nickel come from the D block. So we have to consider the Roman numeral. So we'll still say copper, in this case chloride, except the copper then needs a Roman numeral. The reason it needs a Roman numeral is because it comes from the D block. Now the question is, what is the charge of copper? Again, we're balanced by 2 chlorines. We know that each chlorine has a -1 charge from the periodic table. So the copper must balance out these two -1 charges, which means copper has a +2 charge. So we put a 2 in the parentheses. If we do the same thing with nickel, this would be nickel, and then oxygen becomes oxide. We have to ask the same question. What's the charge of each nickel? Now in this case, there are 2 nickels balancing out an oxygen. Now each oxygen is a -2 charge, which means each nickel must be a +1 charge to balance that out. And this would be nickel 1 oxide. And then finally down here we have what are called polyatomic ions. This is chlorate. This is Nic 8, a clam. So clam, remember the word clam, has 3 consonants. That's why we have 3 oxygens, and 1 vowel, has a -1 charge. So this is chlorate, and we'll simply name this potassium chlorate. Chlorate. In this case, you don't have to. Now, notice one thing very important: chlorate is different than chloride. Now, chloride was just chlorine; it was a monatomic ion. Chlorate is your polyatomic ion. It has oxygens with it. The 8 actually represents oxygens. This is oxygens. So there's the difference between those two. And then finally we have iron and this guy here. This guy is called phosphate. So phosphate goes to the back. And then iron is the first Fe. Don't confuse Fe for, so iron is Fe. And we have to put a Roman numeral because iron comes from a D block. The question is this the iron 2 or is this the iron 3? And because phosphate, because phoenix has 3 vowels, phosphate is a -3 charge, which means there's only 1 iron balancing it. Iron must be a +3 charge. So this again is iron 3 phosphate. And notice the same thing, phosphate at the end. There is such a thing as phosphide. Phosphide would be for the monatomic version of phosphorus. Phosphate is for the polyatomic version. We have a lot of rules and a lot of examples here, so go ahead and practice this on your own. Practice these 3, and then we'll have plenty of practice of this in class. So this concludes for us the lesson.